Welcome to today's lesson. So today we are going to deal with the binomial distribution. So as we have got to know how to apply the combination in probability theorem, we are moving on further with the binomial distribution here. So here, before that, we would like to know that for bi, always when we talk about bi, we are talking about two things, right? So in binomial distribution, we are going to talk about two mutually exclusive events, right? Mutually exclusive outcomes. Are you okay? And always, meaning that here we are going to have two possibilities which are to what happen. For instance, if you take a coin, we know that a coin is having what? A head and what? A tail, right? So it's either you get a head or a tail. So we are having only two what? Mutually exclusive outcomes that we can get. That is head and or what? A tail. Alright, so if such situation happens, we can use the binomial, or we use the binomial distribution to work out the probability of getting each of them. So here, let's assume we were to predict that we have to get a head, right? So we take that one, the prediction. If this head happens, or if we happens to get the head, that means we have gain what we want. So we call it a success. So a success, that means we have gotten our head. And also, if unfortunately we do not get the head and then we get the tail, that means we have failed the test that we need, right? So we call it failure. So in binomial distribution, we label them as success or failure. It's either you gain or you lose, right? Alright, so let's assume if P is the probability, if P is probability that an event will happen in any or single trial, then we can represent P as what? A success. So if P is to happen, right, then it means that the other way, if it does not happen, that means we are going to get what? A failure. So let's represent that one too by Q, a failure. And remember, to a given probability, or the sum of probabilities must always be equal to what? 1. So if we have probability of success plus the probability of what? Failure, we need to get 1. So we can easily say that the probability of what? A failure is equal to 1 minus what? The probability of what? Success, which is P. Alright, so we move on. If we get the probability of this failure, then we can easily work out for our probability of what? An event occurring between these two independent variables. Alright, so let's define. Now that's probability of getting what? An X successes. Probability of getting X successes. Alright, in n independent variable X. Alright, so here the probability function of the discrete variable X is defined as P of X equals this small x here. Then we define it as the n combination of X times P to the power X Q to the power n minus X. Alright, so here we raise the probability of success to a power of X, and then that of the failure to the power of n minus what x, where this n is the number of what independent trials, the number of independent what trials. And we all know the function or the formula for combination, where we have n combination of x, which is simply n factorial all over n minus x all factorial times x what factorial. Alright, so this is how we work for the probability or the binomial distribution. Always we will get a success and also what a failure. So if in a question a success is given, just subtract it from what 1 to get your failure, right? So that's it. So based on, depending on what the question what, or what the probability or what the question is asking us to what do, it will determine which kind of the variables that we are to what represent as our success or what failure. We can talk of, let's say in an examination, if 80% of them what obtain the pass mark, if 80% obtain the pass mark, definitely let me obtain the pass what mark, definitely then the other 20% are also going to what fail, will be the people failing, right, or who failed out the test. So the probability of what obtaining the pass mark will be our success, that is P, and that of this, the failure will be what our failure, that is what Q, right? So you can be asked, find the probability that at least 2 of them will fail the test, will pass the test. So we are going to look at a lot of examples in our next video. So I would like to end this discussion here. So in the next video we are going to take more examples. So thank you for watching, and don't forget to subscribe and share to your friends to also benefit. So this is Owusu Akwesi Frank Chemistry, a student at the Kwame Nkrumah University of Science and Technology. Thank you for watching. Bye.